And Mark. All right. Good evening and welcome to the Research Triangle PowerShell user group. We want to thank you everybody for joining us. This is going to be a fun night. This is the battle royale tonight. We are going to certainly share what I think is the best way to deal with data, and that is absolutely hash tables. Don't you agree there, Mike?
Absolutely not. I hate hash tables. They're a major pain in the ass.
What are you talking about?
PSCustomObject is the way to go.
Hash tables are the bomb.
PSCustomObject for the win.
Got to deal with hash tables.
First of all, never listen to anybody wearing a hat about animal science. That's the first thing, all right? So it's PSCustomObject, PSCustomObject for the win. And to settle this, we've brought in one of our favorite guests of all time. Everybody say hello to Mr. Anthony Howell. Anthony, how are you, sir? Welcome to the show.
I'm really enjoying this so far.
Anthony, we brought you in to talk about
tell you how much hash tables are much better than
your expertise at comparing and contrasting hash tables and PSCustomObjects.
So here's the fun thing is there's actually use cases for both. So the moral of my presentation is, which is better for what?
Well, I mean, look, that's all right, but let's be honest. Phil has to be wrong. I mean, that's just the way it has to go. I mean, so, but thank you for joining us tonight. So to get on track and let everybody know, Anthony Howell is a distinguished member of the community, and earlier this year, Anthony was a presenter at the PowerShell Summit, and I witnessed this fantastic talk he did about comparing and contrasting the use cases for custom objects and hash tables, benefits and disadvantages, and tricks and tips about each one. It was a really fantastic talk, and so we have been waiting a long time to have him come in and join our group and share this information with the greater community. And so we're super excited to have you here tonight. So, do you have a favorite? Let's start there.
I prefer hash tables.
I'm out. I gotta go.
I'll talk about why and give you plenty of evidence to support my opinions. There is use cases for both. I mean, and I don't want to give anything away, but we'll talk about it.
Well, so no, I understand that. I think hash tables are awesome. It just, to me, I find them a little challenging to work with, pulling the data out of them as compared to custom object. That's really the difference for me, is just accessing the data. But I also know that when you need to do large data sets and you want to be speedy, hash tables really are the undenied king. So maybe that's a good place to start, and we could turn it over to you. I'm sure you have a whole setup you want to do about this, so maybe we don't get out of the gate. But yeah, maybe we just start that way, right?
Yeah, no, I got some slides to kick us off, and then run straight into some of the code. So I'll go ahead and share my screen, and we'll get started.
All right.
Thanks so much.
Give me just a second here. All right, and don't worry, it's not a lot of slides. All right, should I leave my camera on or turn it off?
Whichever you prefer. We'll take care of the chat if it's not up on the screen for you while you're demoing. Whichever you like.
Okay, I'll leave it on. I do have two screens, so I'll keep up the chat on one side. So if you guys got questions, feel free to post them in the chat, raise your hand, whatever works. And if I keep droning on, Mike, Phil, please just stop me.
Sure.
So cool. All right. Yeah. So PSCustomObjects versus hash tables. I'll give you guys my opinion and some code to support that. Now, before we do jump into it, this link actually, can I copy this? I can't copy this from the slide. But it's let me just pull it up here. This is where I have everything that I'm going to cover tonight. It's in the repository. I will paste it in the chat for folks. I don't usually do this because I share this last at the summit, so I wasn't able just to paste a link. So it's in the PSCustomObjects versus hash tables. We'll be covering something that's just slightly different from this because this has some PowerShell Summit specific references. I've updated them, and the slides are different. So I don't have the Summit deck. I have my own deck. So anyway, let's run through these real quick. So who is the Posh Wolf? So I go by the Posh Wolf online. Originally, PowerShell. Wolf. My last name is Howell, so it kind of makes sense to me. I like that. But I'm from Eugene, Oregon, and it's probably raining. It's actually not true right now, which I'm a little surprised about. But it rains a lot around here. 4 kids, 2 dogs, and a wife. That's my whole family. My house is very full. I like it a lot, but it keeps me very busy. So the supporting evidence I like to give is if you've ever read my blog, I haven't updated it for it's probably been at least 2 years now, unfortunately, but that's just how my life goes. From a career perspective, I call my career the choose your own adventure style career because I've done so many different things. Started at the help desk, done sysadmin work, field tech. What else? I was a PowerShell engineer for a little bit. Done DevOps, SRE, and actually right now I'm a director of DevOps at Evolent, the company I work at. And actually, Phil, Mike, how long does it take for this to get onto YouTube?
Probably a week.
Okay. I'm gonna be changing roles, so I won't go into too much detail there. But if everyone's ever been a technical person and got into management, you really miss the technical stuff.
That's me right now.
Yeah. So I'm
2 years of management.
I'm backpedaling a little bit, and we're going to be getting out of management. And I'm very grateful that the company I work at, my boss, is open to that. So yeah, just a little plug for them. I always like to give a quick fun fact every time I do a presentation, which actually isn't that often. But my fun fact, we were talking about fisting cows. I have actually delivered a calf before, pulled it right out. And so I just thought that was very fitting given the topic of the night.
That's for the people who were there for the pre-show.
Yep.
Some special fun for you if you came and joined us early.
Yep. So yeah, maybe plug to always join early. Okay, cool. So what I'm gonna be covering today is so for this presentation, I got a little carried away with some images. So if you ever key in the posh wolf into, I think this is from Dolly, OpenAI's thing, this is what comes up. A wolf dressed in a nice business suit. I've never worn a suit like that or watch. But what we're going to cover tonight is we're going to first off, what are PSCustomObjects and Hashtables? If you haven't used them before, we'll cover a little bit on what they are, and then we'll specifically get into how to create them, update them, output them, and iterate over them. And then at the end, I have a really good case study, a real world case study that I did a project where the difference between using one or the other was pretty significant. So I want to talk through that. All right. So for the most part, everything can be done in PowerShell 5 or 7. There's 1 or 2 spots that I'll mention where that isn't true. And so just to give you guys a heads up, I'm working in PowerShell 7 to 4.6 with VS Code on Windows 11. So I don't think that this everything should work in PowerShell cross-platform, and for the most part PowerShell 5. But I just want to call that out because that's what I'm working on tonight. So what is a PSCustomObject? So technically, if you want to get into technical terms here, we're all technical people, so this is important to get into. But a PSCustomObject is a type accelerator. So if you want to know what a type accelerator is, it's just an alias for a .NET type. So really, what a PSCustomObject is you're typecasting a hash table, and it turns it into just a PowerShell object. And we'll get into several examples on how to create them besides just using this one example. And I already have a typo in my slides. Man, I'm good. There we go. I like how this updates on the fly now. Cool. So yeah, that's what a PSCustomObject is. I think between the two, you've probably heard about this one. If anyone has any questions on this, shout them out. Let me know. But we'll probably answer a lot of the questions as we move forward. So, and then a hash table itself. And I actually looked up the definition for this because if you asked me what a hash table is, I would have explained it. Another typo on this one. But the definition is it is a dictionary or an associative array. And so does anyone here like, oh, dictionary? Yes, I know exactly what that is. Yeah, that wasn't me. So the way I like to think about a hash table is that it is a collection of key value pairs. So that's what you can see here down below. So you have a key and a value, and so you input the key into the array to get the value out of it. And that can become very nested. It can be used all different kinds of types. So you can see that I mentioned that keys and values can be any .NET type, and I have some really crazy examples to demonstrate that. But the key here is that, and this is from the help docs, so the help about hash tables. The key here is that it is very efficient for finding and retrieving data. So that's the really big takeaway for hash tables. And that's kind of a foreshadowing a little bit. So I'm gonna update this on the fly. That's gonna bug me otherwise. So let's get right into the demos. And so this is a Posh Wolf giving a demo. Right. So I am in VS Code. I am in this my sessions repository. I've made some bulk updates to update some of the references from the PowerShell Summit to the user group here tonight. But if anyone wants to follow along, all this code it exists in the main branch of that repository. So we're gonna run through these. Let me zoom this in a touch. Get rid of the site. Is this good?
Yeah.
A little bigger? Oh, that's good. Okay.
Yeah.
Cool. Thanks, Mike. All right. So what we're gonna go through is we're gonna walk through. Start with hash tables here. And several different ways you can create a hash tables, and we'll get into PS custom objects and go from there. So the most PowerShell-y way to create stuff is using a verb noun command, right? So using the new object, we can do that. So I'm gonna run line 2 here, and down below we can see the output. And so if we look at that at $HT, short for hash table, it's empty. There's nothing in it yet. The way that I always create it, and the way you'll probably see it most often, is with the @ symbol curly braces. It's the exact same output. It's just the different a shorter version of doing it. And there's also a lot of ways to add values to hash tables. And the .NET method to do it is using the .add. And so in this case, if actually we hover over add, we don't get the help in VS Code, but it takes the key and the value. So the key is on the left, value is on the right. And actually, let me try something here really quick. Has anyone here seen Zoom It? I just got Zoom It. So there we go. Key on the left. Value. Woo. Okay, I'm not very good at that.
I can never remember the Zoom It.
Yeah, me either. Yeah, me either. I just got it recently, so I've been playing around with it.
I use it all the time, and I always forget the shortcuts.
Nice. All right. Well, that's why they have like that nice shortcut page online.
Yeah.
So I'm gonna run lines 10, 11, 12, and it's gonna add each of these key value pairs. So we have event, the name of the event, research triangle PSUG, the date, and the location. So now if we look at 13, we have name and value. As you can see, all three of them end up into the hash table here. Sweet. But the easiest way, the way that I always create hash tables, is to do this with the @ sign curly brace, and then their key values, and it's quick. It's less writing, easy to understand as well. And if you have auto formatting in VS Code, it does this spacing for you automatically, and you get the same output down below. Same thing. And of course, there's always in every PowerShell group I've been in, there's always somebody who's all about doing it in one line. You can do it in one line. PowerShell, you separate with the semicolon there, and same thing. So one of the interesting things is you look at this output and you're like, well, there's name and values. And so if we try to sort it, it doesn't actually work. And that's because it's passing the entire hash table down the pipeline as a single object. Whereas the getEnumerator method, what this does is it creates each item in the hash table passes as a distinct object. And so that allows us, line 29, to actually sort it. That doesn't actually look like it did sort. LED. Oh no, I do know my alphabet here. Let's take that descending out of there.
Yeah, descending.
There we go. Sorry. So that's a really good point, and that's probably why I had ordered next. Or I shouldn't say that probably is. It's why I have ordered next. Is that a hash table is not ordered. So what it doesn't care what order you put the values into the hash table. It will just store them in a random order. And there might be some logic to it. I don't know what that is. But if you do need them in a specific order, oh, am I keeping my characters flying? Oh yeah, my 24. Thanks, Steve. If you do want to keep them in order, you have the ordered type. So we're now casting the hash table as an ordered hash table. So now if we look at this, event date location, and now the outputs as event date location, so EDL. If we look at the actual type of this, so .get type, we can see that it's an ordered dictionary. Sorry, I called it an ordered hash table. My bad there, but yeah, it is an ordered dictionary.
So let me just point out, because you're using 3 examples here, when you did the sort on 28, you did descending, but if we just did, if you did, when you were doing the sort, because you sorted 3 objects, it just turned out that sort and your ordered, you put the ordered in alphabetical order. It didn't have to be that way. You could have ordered it however you wanted. That might not be obvious to people.
Yeah, that's a good call,
Right.
Mike. Let's look at this. So if you look at 28, and I'll do this twice now. So 28, so we got location, event, date, and if we do descending, which will order it the opposite way, there's no difference. And that's because on line 28, the hash table itself, while it is a collection of key value pairs, it's a single object being passed down the pipeline. And so on line 29, the getEnumerator method, it takes each item in the hash table and passes it as a distinct object. And there, that allows us to actually sort it. So you can see we can sort it ascending, or we can just sort it descending, and they're different in this case. So it is actually able to sort them. Yeah, we got a hand up. Who's that?
Yeah, Anthony, if you're gonna press keys to do functions like F8 or whatever, would you mind turning on screencast?
Yes.
VS
Yes, that is. Thank you. And is that going to work? Ah, yes. Thank you, Steve. I always forget about that.
Yeah. So what we were pointing out is when you make an ordered table, if you had 30 keys in there, you can order them in whatever order you want. It doesn't have to be alphabetical. That was the point I was trying to make, which Anthony was just highlighting there a little bit.
And I want to point out too is that it's kind of like in the code and kind of like, hey, you can kind of go over it. Is this idea of like at 29 is that if you do have a hash table at that point, there is this thing called hey get enumerated, kind of fold right over it. Is the hey get the pieces out of it, and so that you can just rip the whole thing apart, and so now make it individual objects that you can pass down the pipeline. And so then you use sort as a separate thing. So kind of to Mike's point is that you can do sort, and in this case, that it only has one property called name, but you can do multiple properties over time. But then you're just using all the power of sort and all those other things down the road. And so you can do where in the middle of sort, so you can pull apart the hash table, do like a where in the middle there. So you can, the world's your oyster at that stage, but that get enumerator is also one of those like gems that if you see it and you go, oh, you just fall right over it, but it is a valuable tool there. So go, Anthony.
Yeah, that's a good call. And I have some more examples specifically with get enumerator, but I saw one question from Mark in the chat. To be able to sort, it's a thing because the hash table itself is a single object. So to compare it to like a PS object, it's like trying to sort the properties on a PS object, and that is more complicated than sorting an array. And we'll get into some more examples to explain that a little better. And I mentioned that. Oh, whoops! Sorry, that was wrong. There we go. So I mentioned that you can also nest hash tables, right? So this is starting to look, something along the lines of, some JSON, for example. And the really cool thing about newer versions of PowerShell is you can see some nested properties depending on the type of objects. I think we talked, beforehand, that to be able to see this, the object has to have a toString method, and in this case, all of these properties do. We don't see the type name. We do see the actual values themselves. And the size, the size doesn't matter. We can make this huge, and this is just a random example. So this is a hash table of hash tables. So you can see in this hash table, the first key here is this date. The second key here is another date. So actually, let's, instead of just pointing at the code here, if we run this, we can see that in this large hash table, this output down below, this is two hash tables. Each of them have nested properties, and we can see very specifically that if it gets too deep, we start seeing the object types. So it's literally, PowerShell in the background is literally doing the toString method on the this hash table right here. And anytime you do hash table, we can look at it, hash table.toString, we get systems.collection.hashtable. Cool. So, and another, and this gets really confusing, but you can have an array in a hash table. So in this case, we know this is a hash table based on the @curly brace. And inside of the hash table, we have an array, and this array is called events, and that's all that's in here. And inside of events is an array of hash tables. And this is where it can get really, really confusing working with some object types. So I'm gonna load this in, and if we look at array hash table, oh my goodness, I can't type. That's why I have it up here. Let's do that. We get one property in this array, which is events, which is what we expect because it's the only property in here, and we can collapse this and see that that's true. And then if we look at .events, we now get an array of hash tables, and this output sucks, by the way. This is one of my biggest gripes with hash tables. If you're working with an array of them, where does one stop and where does one end? Well, in this case, there's only 3 properties, so it's pretty easy to see that. But in larger larger objects in the array, or larger hash tables in the array, it becomes very difficult. And we'll talk about how to get around that. And so we can also create, there's another example of creating an array of hash tables. So in this case, enumerating it all inside of the pipeline. This is a much bigger array. So for example, this output is going to look even worse, right? So while they are very fast, they don't scale well for output specifically, and we'll look at some examples on how to fix that. Other places that hash tables can be used, at least that I found that was noteworthy, is sort object has this that expression method of sorting hash tables, or sorry, of sorting objects. So in this case, I'm passing an array of hash tables, and I want to sort it by the date.year. So if we look at array of hash tables, we look at the first one, .date.year, we can see that's 2024. If we look at just the first hash table in this array, since this is an array, I can use the index operator, so the square brackets, to look at the first item, and we can see that it's just a hash table, right? And so I'm looking at the date.year. So if I want to use a hash table on line 134 to actually sort by that specific year, since this is an array of hash tables and not a single hash table like we looked at before, I can actually sort that, and we can see that we now have 2030 at the top and 2024 at the bottom. This as an example. And one of my favorite things in PowerShell, I can't remember if this was 6 or 7, but convert from JSON has the dash as hash table option. And so I have some mock data. We're going to use that for a demo in a little bit, but we can pull this data in, and then we can now you can see that this data is a hash table. And this is fake data. Don't worry, this is not anybody here knows. And to push the point home that you can use whatever object types you want for the keys or the values. This is a valid hash table. I've got booleans, I've got an integer, I've got a string, I've got a date time object and a process object. And this, it looks weird This would never actually be a good idea. Oh, I'm not running elevated, so it's going to be a couple errors. That's okay. But that is an actual hash table, a legitimate hash table. It doesn't care what the key or what the value is. I mean, if we look at hashtable.add, so the method we looked at earlier for adding values, it'll take a system.object. So that's literally the base object in PowerShell. It'll take anything as the key and anything as the value. So I just wanted to demonstrate that. Dave, good question. Casing is actually important. This is the one of the few places in PowerShell where casing is actually important. So let's look at hash table. So we have hash table location with capital L. Look at hash table and we go location. Okay, maybe that was a trick question. In older versions of PowerShell, it did actually matter. At least I swear it did. Let's find out. I'm now really curious. Let's find out. Where's my simple hash table? At the very top, I think. Yeah. All right. So I'm gonna take this, copy this. We're gonna test this in Windows PowerShell and see if Windows PowerShell is gonna make me a liar. All right. Sorry. It used to. I've been doing this a long time.
Casing doesn't matter, and you can't have duplicate keys in a hash table, and it will see the same word in different cases as the same key, though you can have a JSON object that has the same key with different cases and convert it to a hash table, and that works. So it's weird.
That's some good insight, though.
That's what I was actually getting at. Yeah. Thanks, Sean.
Cool. And yeah, in the comments, yeah, James says it sticks at some point. So dictionaries will be case sensitive by default. So in this case, we look at hashtable.getType. This is actually a hash table, so we created a dictionary. That is where it would be case sensitive. Okay. Oh, if you create a hash table with new object, let's try that. I'm gonna try that here. We're gonna do it like this. Hash table like get type. Same type, but let's try this. Now I'm curious.
So I feel kind of duty bound to kind of explain what I've figured out over the years. PowerShell's doing this trick. You create hash tables with a comparer, and when PowerShell sees a hash table, it's actually creating them with a case insensitive comparer. And same thing's true for ordered dictionaries. Okay, can you guys hear me?
Yes.
Sweet.
I can hear you.
So both hash tables and ordered dictionaries in PowerShell have this extra tiny little tweak, which I think we covered in our case sensitivity training, that makes this easier. But there are lots of dictionaries that you will run into all across PowerShell that will be case sensitive, like, a dictionary of query strings. That's going to be case sensitive. So these two dictionary literals are the only time when dictionaries are going to be nice to you in case in PowerShell. Every other time, they're probably going to be mean.
So the takeaway there is to always be careful about the case.
Yes. And the case sensitivity training is really fun.
I appreciate
Just in
that joke.
case.
Yeah, and I've been there troubleshooting a weird bug and have found out that it was just a casing in one of my hash tables. So that's a good call out. All right. So let's take a look at PSCustomObjects. If you guys got comments, feel free to stop me at any time. I'm just going to keep trucking unless I hear otherwise. All right. So the PS object itself is, like I mentioned before, like the base object in PowerShell. Everything inherits from that. Because PowerShell is built on .NET. .NET uses object inheritance. So creating a PS object, you can do it with new object, right? And we get new object, we get an object with nothing in it, empty. And does anybody remember PowerShell v2? This is how you used to create objects in PowerShell v2. Does anybody miss that? I don't. And
Nope.
so one of the updated ways to do this is you can use a hash table to create a PS object, using the new object command. And so if we do this, we get the same thing as before, the same object, nothing different about it. And of course, and this is a PowerShell v3 thing, we got the type accelerator PSCustomObject. So this is what I mentioned, in the slide deck. It's literally just typecasting a hash table. It's a shorthand version of doing what we looked at before, and they all get the same output, right? And of course, this can be done inline. There's always that one person that always is all about one-liners. I don't know how PowerShell attracts those kind of weirdos, but you could do that in PowerShell. And we had an example with a hash table creating an array. And so we can create arrays of PSCustomObjects. And a comment from Sean: using PSCustomObject is much faster. I have some speed comparison, and that's not one that I have in here. So that's a good call. Thank you for that. But a lot of .NET stuff is faster than using PowerShell functions or commandlets. So creating arrays of objects, this is something that everybody in PowerShell should be familiar with, right? We get this array, and we know that we can sort it really easily. We can do sort object, we can do where object, and actually, hang on, since the output is not a little restricted here, you can see that sorting actually works here, right? So a hash table where it's a hash table of keys, a single object, you can't sort that, but you can sort an array of PSCustomObjects, just like any objects are. And nested properties in here. Let's get rid of. Whoops. There we go. Nested properties in PSCustomObject. You can get really fancy and create this really nested thing, or you could just create JSON and convert it. Whatever you prefer. And it comes out as these nested objects. And I'm going to say this again. I love this output where we can actually see, as long as it's not nested too deep, and the nested type has a toString method that works. We can see some of this nested data, which is really cool. And like hash tables, we can convert from JSON, and we can get actual objects. So you can see this is an object, not a hash table before, where it was key values. And so the question is it faster to convert the same data from JSON to a PS object or to a hash table? That's one of the questions I would like to answer here. So here we go. I'm doing it as a hash table. I'm doing the same file 10 times, and then just getting it by looking at the milliseconds. So this is converting it from a JSON as a hash table. So we got 887 milliseconds, and doing it 10 times just as a PSCustomObject is faster, and that is the complete opposite of every other time I tested this. Let's try that again. I literally just ran this last night, just ahead of time. All right, so it actually is a little slower. I'm now questioning my entire existence, guys. I'm gonna try this one more time. I got 781 as a hash table, and 786. All right, well, that's I'm a little taken aback. Previously it was faster, so maybe it's not always faster. Maybe there's something going on. I don't know, but I guess that kind of kills the moral of this little section. Yeah, they must be close enough that it's not much different. Yeah, do it 10,000 times. Yeah, right. Oh, okay. Why not? Let's do it 100 times. All right. Don't want to take too long here. So total milliseconds, doing it 100 times. Maybe 100 times was too many. Reading a file is, yeah, you're probably right. Reading the file is probably taken. That's a really good point, actually. So a little over 6 seconds from a hash table, and then the actual PS object takes 8 seconds. Okay, there we go. That's more what I was expecting, but I was expecting that, in a tenth of the time. So anyway, let's move on. If this is one of the big reasons I first started using PowerShell Core, the as hash table property. Fun fact there. All right, so let's take a look. So we looked at creating, let's look at updating these guys. So let's get to the top of this. So we already have, HT is already a hash table that exists. So I'm gonna look at hash table. You can see down below what we've got. So if we wanna change the location, we can use this this index notation here on line 2, and actually just update the location, and it's that simple. We can also do this using dot notation, and that also works. So you can see down below the location is Seattle, whereas it was Redmond. And this dot notation, this is a I don't recall what version, but this is in the newer versions of PowerShell. And let's see, someone commenting about when you create a class that you want to see actually serialized, you can override the toString method to output an easy read string. That's a really good point. And we can also add properties. So if we look at this hash table, there's no military time property, right? But we can add the property using that same method that we would use to update the property. This is actually really slick with hash tables, right? So we can see now down below, we have the military time property. Cool. And can we do the same thing with dot notation? Let's find out. It didn't get an error. Yes. So dot notation works too for hash tables. And we'll look at the same example with PSCustomObjects. And we already saw the add method previously when we created it, but I just want to call out that that's also a way to add properties. And it's also a way to remove properties. So you can see down below we do have, let's see, time zone, and to remove it we just specify the key name. We don't need the value in there at all, and that removes. So you can see down below we now no longer have the time zone property. And if we want to find all of the properties, the easiest way to do that is to look at the keys property on the hash table, and it'll list all of the keys for you. And so if we want to find if a hash table contains a specific key, we can use the .contains method. And I think there's actually a contains key method. James is going to give us a quick speech on why one is better than the other, right? Or was that only for the summit? Oh, James must not be listening. Sorry, he brought that up in the summit, and I forgot to actually update the script. But contains key is the correct one to use here. So contains ht.contains key location, or you can use ht.keys -contains, and either way works. But which one's more efficient? Let's find out. So we're doing gonna do 10,000 times. Oh, was it the opposite? Oh, okay. Sorry, I'm looking at the chat. James says .contains because it also works on a dictionary. So .contains works on a dictionary and a hash table. So I did actually save the updates he suggested. All right, I'm feeling a little better now. So which is more efficient? So we're gonna do it 10,000 times. ht.contains and then ht.keys -contains, and this will definitively tell us which one's faster. So .contains a little under 40 milliseconds to do 10,000 times, and -contains 37 milliseconds. That is again the opposite. Man, it's opposite night, guys. So 32 and 13. Oh my goodness. So I'm gonna give an example where this is actually the opposite. Oh, we got some output. Which Sean, which one are you testing there? Oh, doing the new object versus the PSCustomObject, and which one's faster? Total. Okay. So in the chat, Sean posted an example using the PSCustomObject type accelerator is faster by 6.5 versus 33.5 seconds. Nice. Yeah, thank you for that example. So right here, .contains and -contains seem to be about the same. If we get into larger hash tables, that's where it becomes .contains becomes much faster. And I have an example where we're going to look at that. So the last thing I want to mention here is that we can access properties with a variable. So this comes in handy if you don't know what property you're going to be looking for and you need to use a variable to find it. So for example, if I assign location to the property variable, if we'll actually just look at this, we can see that property now is a string that contains location. We can do ht dot property, and that returns the location property of that hash table, or ht with the index operators there, and it does the same thing. So very useful. And if we do look at the hash table, we can see that yes, location is actually Seattle, Washington. So cool. Let's look at the same things, but for a PS custom object. All right. So we have object, which is just pretty basic object, event, date, location, right? So location exists. We can update it in place, and we can see that now the location was changed to Seattle, Washington. But unlike hash tables, we can't use the dot notation to add a property. We can see that we get it cannot be found, verify that it exists, and can be set. So we can still use the add member commandlet to add properties. So if we look there, now we can see we used add member. We got military time. But the interesting thing is you can actually use a hash table to add multiple properties to a PS custom or just a PS object. So here, add member, we're using the dash note property members. We're using a hash table of keys and values, passing it to an object. And there we got multiple properties now. And this is the fun one I learned at the PowerShell Summit a couple years ago. So very very useful if you got, instead of doing if we looked at the the first PS custom object script we covered, there's a row of add members. In this case, you can just use add members with a hash table notation. Now another really interesting thing, if we want to add we can get really fancy here. If you're not familiar, the PS object property exists on every object in PowerShell, and it has a lot of metadata about the object itself. Oh, thanks, Sean. I appreciate your input, your interactions as well. Sean's dropping. So if we look below, we could see in this object we've got these members, these properties, these methods, and then some information about the object itself. So type names, for example. And this is something that you'll never use, but I figured it out just to show this off. You can use psobject.properties.add and add a new note property using this method. Never do this, but it works. So you can see we added address. So we can see address here, 123 Main Street. James is saying this is the fastest way to do it. So maybe there is a use case for it. It looks terrible. So if you ever do this, make sure you add a nice comment explaining why. If you put true after, that's the only way. So add has it, okay. So according to James, if you add true, so are you saying right here, true? All right, let's find out. Yeah, all right. Cool, that's the only way to override properties. Interesting.
I don't understand. I don't understand how that is the fastest way, because that literally seems the slowest way to actually have to type something. Where does the fast come in with that? Like, I'm just curious.
Performance. I would guess the execution of the script itself. It's fast because it doesn't run a command. So fast.
I guess I understand that, but I mean, I guess I'm splitting hairs, but this time to write the code, right?
Yeah, well, so if you're interactively, it's not fast. There you go. Running a script to run, perform a script to run later, it is faster. So depends on your time versus the execution time, which was more valuable.
Yeah, and I think if you're doing it at scale and you're inputting data into the hash table and then pulling it back out, it's a lot faster. than the other way around.
Yeah, well, this is PSCustomObject in this case, but yeah.
That's what I'm saying. Sorry,
Yep.
I used the wrong word.
Cool. And so removing properties from an object, we can use the properties.remove and give just a string, the name of the property. So we can see address exists down below, and now it does not. And now I'm actually really curious: is there a remove member? Nope, there's add member, but there's not a remove member commandlet. Nice. So printing properties. So I'm adding some of these examples here to kind of compare to hash tables. Like we saw the keys with hash tables, see all the properties. If we look at the PSObject.properties.name, this gives us a list of all of the properties that are on that object. And so if we want to, and another way to do this is with getMember. So getMember returns, well, if we just look at just what getMember returns, right? It returns all the members on that object itself, including both methods and properties. But if we specifically filter down to no properties and the names, we can get the same thing, using the pipeline. If you guys prefer pipeline versus, methods on the objects themselves. But as we covered earlier, methods are faster. So speed versus, well, actually, it's both faster to type and faster to execute. So if you want to test a PS object to see if it has a specific property, we can use the -contains location, right? So since properties.name, this is an array of strings. -contains is a comparison operator we can use on arrays of strings. So down below we can see that yes, it does contain location. Or we can use the hash table notation to see if it's in there or not. And if this returns a value, it obviously is in there. And if it doesn't, it doesn't. And so another really cool way to access properties on a PowerShell object is we're using a variable. So we can do the same thing we did with hash tables, right? We can do object.property. So this is property again, like with the hash table, is a string. It's a string. It says location, right? So we do object.property. These are two variables. What the heck? It actually works. So this can be really useful if you're working with custom objects that may or may not have specific properties. And then line 42, you'll notice that the index operator does not work on a PSCustomObject like it works on a hash table. So that doesn't actually return anything. So just a call out for that. Sweet. Let's look at outputting. So this is where we run into some really funky stuff with hash tables. Well, and with PSCustomObjects. So we've looked at outputting a hash table, right? It's not fancy, it's not great, but it works. We can see the data, and as long as it's not arrays, then it's very easy to understand. And we've looked at grabbing specific properties. But one thing that's interesting, and I have this at the top because I only learned this recently, is that you can actually use the index notation here, the square brackets, to select multiple keys out of a hash table. And that returns only the values of those two hash tables, or sorry, the values of those two keys. And it returns them in order. So event location, and it returns them as a string array. So as I mentioned earlier, and I'm just going to reiterate this, arrays of hash tables look terrible. They're not. The output is not easy to understand. And just to really drive this home, even with formatters, man, we could format it as a list, or format it as a table. Like it's not. We're not going to make this any better. So one way to do this is you could format it as JSON. I really like serializing to JSON. And that is a decent way to look at JSON or hash table data if you absolutely need to not convert it to something else. So we looked at a single hash table, looked at an array of hash tables with nested properties. We can see some nice output here. Sorry, I forgot we had this select object part. We can also select specific properties. And this is an array of hash tables, and I'm selecting the event property. But interestingly enough, this doesn't work in PowerShell 5.1. And I do know this one for sure doesn't work because I did test this one out ahead of time. Let's create that array of hash tables really quick, and we're gonna, array of hash tables, and we're gonna actually demonstrate this in PowerShell 5 because I feel like at this point, if I say something is not going to work, it may actually end up working like before. So if we look at array of hash tables, so I'm in PowerShell 7 below, and it actually works to select that single property out of an array of hash tables. And in PowerShell 5.1, it doesn't actually work. So I was right that time. Oh, nice. Yeah, so Dave's posting some more advanced ways to set multiple keys. So if you guys want to see a good example of that. Oh, so here, actually, I'm gonna take that, Dave. Yeah, thanks for pasting that in here. So what Dave did is since this returns an array of strings, he's assigning them to multiple variables. And now if we look at event and location, there are two different values. So that's a really fun example. Thanks for sharing that. And I think I've seen other places where you can output into multiple variables like this. I'm not super familiar with that, so I'm not going to talk about that too much. But Dave, yeah, thanks for that example. Let's see where we're at. So we were select object worked. So outputting these to files. So a hash table, for all intents and purposes, is treated very similarly to a PS object. So if we do a convert to JSON and then output to a file, it outputs to output.json, which JSON file, exactly what we expect in this case. And then if we can output it to a CSV as well with the no type information. And this is where we get some really weird output. And I'm not sure if this is similar to what one of the issues that came up in the earlier. Oh, nice Rainbow chat earlier, but because location, and we'll look at this one. Actually, let's look at the JSON output so we can open them both at the same time. So in this case, location, we're getting the type, right? It's a hash table. So if we look at location, in this case, location is a complex object, so it has sub properties, and so that's why it is. So PowerShell is literally doing location.toString, and it's a hash table. So it's hash table.toString is just the object type. That's the default behavior. And then the event itself is PowerShell Summit 2024. I didn't update this one to be Research Triangle PSUG. And then again, since date itself is another complex object, it outputs as the property type in a CSV. So in this case, JSON just better for this type of object. Cool. So, but the best way to output hash tables is to convert them to PSCustomObjects. So I have here, I'm literally just piping hash tables and then using the PSCustomObject type accelerator, because all it does is typecasts hash tables, and I have an array of hash tables. So this gives me some nice looking output, and it's very, very performant. And then I also have an array of hash tables where I use the new object, PSObject, and that also works. And I do actually have an example. I just contextually wasn't thinking about this. But the example here, so we're gonna do it 10,000 times. We're gonna convert this array of hash tables using a type accelerator. We'll see how fast this is. And this takes 309 milliseconds on my system. And then using a new object, PSObject, this takes 740. So this is a significant difference, and it is actually working the way I expected. Cool. Yep. Thanks, Roy. Roy's saying good night. I think I saw other couple folks saying good night. Yeah. Thanks for joining. I think my wife is probably putting my kids to bed right now too. Cool. So the moral here is that the PSCustomObject type accelerator is faster than using new object with a hash table. Cool. And we have some other morals, so stay tuned. So let's look at PSCustomObject. So PSCustomObjects, I mean, PowerShell is built around objects. So format table, format list. These are all run natively with objects. And we have too many properties. That's where it defaults to formatting as a list. So if we look at like an array, so objects is an array of PSCustomObjects. We can also do this as a list and as a table. And this is very clear delineation between different objects, unlike with hash tables. I actually, the question is how much longer? I didn't actually see what time did we actually start? Was this around let's see, Eastern, right? So 8:30.
Dimitri, we have probably another 3 hours.
I would say 30 minutes tops, and that's depending
we'll
on
be on YouTube anyway, so we'd be
okay. We can make that longer. All right, everybody, fire up questions. No, I'm kidding.
No, I've got the time. So if you guys do have questions, spit them out. We'll get some cows on here. Yeah, good call. Okay, so let me get back on track here. So select object, that's another one. Select object works natively with PS objects. And one of the really fun things is this is kind of long to type out, but you can use hash tables to create expressions inside of using select object. So we've looked at objects itself specifically. Date is just a 2024-4-10. It's just a string here. And using date time, we can actually cast that to a date, and we can do this in line using a hash table in select object. So now we have date. The date column is now an actual date time, which is cool. I personally don't do this a lot because it gets confusing, especially when you do it on one line like this. I'll say it again. People that do all the one line stuff, they need to learn about splatting. So objects, it's very similar to outputting as with hash tables. Converting to JSON, exporting to CSV. I'm overwriting both output.json and output.csv, but we get very similar things. And I output it in this case as simple objects, so there aren't any sub-properties here, so we actually see the full strings. So it is what we expect. And then the output.json, again, is what we expect. We get the array notation and then the actual objects themselves. All right, so another thing that's really cool with with objects in general is that we have output formats. So if we look at this output, for example, from get process, we don't see the full object. That's intentional. I mean, there's way too much data in there. And the same thing for this. The first example was with processes. The second example was with services, and each of these do have much more data than what we see here. So for example, if we go, get process, and we look at the first one, and we pipe that to format list. I guess I'm not running it. I'm not running elevated, so we don't see all the properties. But something else that's really cool in the newer versions of PowerShell is you'll notice that some of these headers are italicized. That indicates that that's a computed property, and you can't actually access a property called .cpu and then s inside of parentheses. But we can also take and apply an output format to our own PSCustomObjects. And this is not I'm not going to get into how to build an output format. There's a lot of ways to do them. This is a very simple one where I'm calling it my type view for a type called my type. And I'm saying it to make table columns with date, location, And then you can see width and alignment there as well. And then there's date and location. All right. Don't ask questions about that because like we could spend a lot of time talking about types. So I have this as a PS1 XML. I'm going to import that with update format data. And then so object itself, when we look at object, it's a PS custom object that I created. And so what I'm going to do is I'm going to look at, so if we look at the type names property of type names property of PS object, we can see that this is a PS custom object which inherits from system.object, which is the root type there. And so if I use this .insert method to insert my type at the very beginning, we now look at PSObject.type names, and we can now see that this object, the PowerShell now thinks that this object's type is my type, right? So now, since we've imported this type data and told this object that it is my type, we now get that that output format. So now we only see date and location, even though we know that object has more than just date and location. And so this is a fun trick to do if you don't actually want to write classes. If you want to just freestyle it with PS objects. And I've seen a lot of modules do this very successfully. And then if we want to convert that PS object into a hash table, what we can do is we saw how to get an array of the property names, right? And we know that we can use that property name as a variable to access the value itself. We can convert a non-nested PS custom object to a hash. Well, we convert any, nested or not, we can convert it to a hash table, but any sub-properties would not also be converted by declaring our hash table here on line 29. And then for each property in the properties on that object, creating a hash table hash table key with that name and the value of the value of that property on that object. And so if we run that through, we now get a hash table of that object. And that can be useful at times. Not always, but it can be useful if you need to convert an existing object. So, and if you have nested properties and you want to convert them to hash tables as well, you'd have to do some additional logic. Yeah, question from Steve.
That was exactly my question, is how would you handle nested properties? Nailed it.
Yeah. We could spend a lot of time talking about logic for, testing each property to see if it's, if it has sub properties and other things. But this is just a quick and dirty way to get all the root level properties converted into, hash table keys and values. Oh, nice. Got an example in the chat for adding add member type names. Nice. Yeah, thanks, Dave. Yeah, and recursion. Yeah, you could use recursion. Probably use recursion to do convert nested properties in a PS custom object into a hash table. So okay, let's look at iteration. I got some really fun examples that will probably full understanding will probably require looking at these after the session in more detail. But we talked about get enumerator. So this hash table, this is the same hash table we've been abusing this whole all night. Now, if we look at get enumerator, the output doesn't look any different. But the difference is that get enumerator, like I mentioned earlier, takes each key value and sends it down the pipeline as its own distinct object. And we know that because we can do for each object, we can do key value. So in this case, the key will now be a key property on the pipeline object, and then the value is now the value property. So if we run this code, you can see, and this is pretty janky output, but it gets the point across. So the event key has the research triangle PSUG value. And the other way to iterate over a hash table is using the keys. It's usually the keys property itself, and the for each we look at the key and we look up the value in the hash table based on that key. So we get the same output, it's just a different way of doing it. Generally speaking, I personally prefer to iterate over the keys property. And let's see if, I'm not going to say anything beforehand, so let's see which one's actually faster. So get enumerator, we're going to use that get enumerator 10,000 times. And that takes about 196 milliseconds. And then if we do the, for each key, output this 10,000 times, that's slightly faster in this case. And do I risk running it again just to be sure? Let's do that. 163 and 143. Okay, so it is consistently slightly faster at least twice in a row. Another way to do this is we can use a for each loop. So for each key and ht.keys, output these values. So it doesn't have to be a for each object. We got a comment saying if you had a larger hash table, it would be the opposite. That's a good question, actually. I'm not actually sure. If this hash table was larger, is get enumerator faster than iterating through the keys? That's a good question. I'm not sure. If we have time, maybe we can come up with an example, do some testing on that. And then of course a lot of good funny jokes going on. So for loop. So can we index into the .keys array? And the answer is no. And it's because if we look at ht.keys, we'll find that it's ht.keys.getType. It's not just a string or this string array. It's a key collection, and that we can't index into that. Now, and so another caveat is if you are indexing through the keys property, you can't add or remove keys. Otherwise, it'll throw this error. Collection was modified, enumeration operation may not execute. But we can't, so for example, this example is trying to remove all the keys, right? And we only were able to remove the first one, since that's the only one that completed and it errored and exited out of the for each loop. So just be aware of that. So iterating over an array of hash tables. So this is where we're going to start to really think deeply about these. So we have an array of hash tables. We can see that we've got a bunch of them. I think it was 10, right? Maybe not 10. Yeah, it doesn't matter. Now, so if we iterate over each of these items becomes a hash table every time it iterates through the for each loop. And so there we can see, this output is terrible again. Sorry, it's janky, but it gets the point across. Oh, here, hang on. Let's do this. Yeah. Okay, so there's one hash table. Or wait. What if we do this? Okay, there we go. Oh, well, okay, I'm not very good at using Zoom it. Sorry, guys. So we have, see the event is the event, the date, and you can see date is, since it toString the date, it came up as just the property name. But we can iterate over the array of hash tables that way. And this is where we're going to have a lot of fun here. Let's clear out some of the screen. I'll go away terminal. So here I have a very nested hash table, and I'm ordering it for ease of viewing. So I have very nested hash table A, A1, A2, and then A3, right? And then B, A1, or sorry, B, A1, B1, C1. So you can see that we're going what 1, 2, 3. We're going three levels deep here. And we're going to add this into our session here. And if we look at very nested hash table, we can't see all the way into it. The comments are gonna make me laugh here. But if we want to iterate through this very nested hash table, this is where I'm actually going to expand some of this a little bit. So remember, we've got A at the first level, A1 at the second level, and A2 at the third level, and then the value is actually A3, right? So for each key in very nested hash table .keys, so this is the first level of keys, we are going to pull all of the sub keys from very nested hash table key. So now we're at the second level. And then we're going to go down to very nested hash table key, subkey, dot keys, and finally, to get the very deepest value of the hash table, we get this line 118, very nested hash table key, subkey, subkey. This looks crazy because it is. But if we look at this output, you can see down. Then now we get the sub value is that value that we do expect. So, but what's interesting is this isn't very easy to read. Right, we get these long lines, and if you have long key names, it can look really awkward. And so what we can do is to make this a little easier to read, and we can so we're getting the first set of keys. We're taking this first hash table and assigning it to a new variable. And then we're getting the keys from that variable, and we're assigning it to, going through those keys and assigning it to a new nested H1 variable, and then going all the way down and getting that final value at the bottom. And if we run this, you can see that slightly different names because we went with nested H1 value. We get all the way down to A3 again at the very bottom. So all this is to say that one of the things that makes hash tables difficult is this. This type of a notation. You look at this and you're like, okay, well, what does this actually mean? And you have to read through this whole for each loop to really understand. And this can make it somewhat better, but again, it's still confusing. So in my experience, this is one of the reasons that people don't use hash tables a lot, is because it can be very confusing to understand. And so this is where it's very important to use names that make sense when you go through each of these, if you were to iterate through a nested hash table like this. So nested, that helps, right? But you may have something more contextually relevant if you're working on some other form of complex objects. So just be aware of that. So let's look at how we might iterate through PS custom objects. All right. So PS custom objects. So we have an array of objects again. This is just from earlier, right? Same thing we expect, and we can iterate through it. Now this is same output as we looked at with the hash table. For same dot notation that we looked at before. We can pass it to for each object. I'm really hoping these are refreshers for everybody because we all work with objects a lot. We can iterate through it using a for loop. And when would we use a for loop over a for each loop? Well, maybe we need to keep track of the count or the index we're at, right? We can get fancy. We can use a while loop. I mean, we can. There's a lot of ways to do this. I was kind of going crazy with these, and I decided to stop at while loops before we got to do whiles. But we want to iterate through the properties specifically, and we've looked at ways to do this before. But we can look at the PSObject.properties property of the object, and then we can get the property name as well as the property value. So just like in a hash table, we have key, we have value. And I didn't want to get into an iterated example, a nested example in PS custom objects because it's not as much of a headache as it was with hash tables. All right, Mark, have a good night. And so finally, let's look at the case study. So this is a I did a project a while back where using hash tables made a significant difference in performance. Oh shoot, and I totally forgot to remove the okay, everybody close your eyes. I'm gonna remove the timings from some of this, and then we're gonna look at, okay, cool, I remember to remove it from most of them. Okay, so I worked for a company a while back that had this really weird setup where we had multiple distinct directories, and we had to they finally decided, well, it makes no sense to maintain user accounts in multiple Active Directories and then separately, not synced, but separately in an SSO provider. And so I had to go through and compare thousands of users between multiple different directories with different unique properties. So they didn't all have the same UPN, for example. It might be email in one place, username in another. And so I had to do this comparison very quickly, or I didn't have to. I wanted to do it very quickly, right? So what I'm gonna mock for you guys tonight is just an example of how to do this. Actually, let's look at this. So I have mock data. This is absolutely fake. So users one. So the first. So this is just a generic like user object. Just trying to mock that concept here. And so I've got the ID of 1001. And so what I'm so I got 10,000 users actually. So I'm only grabbing the first 5,000. And what I want to do is out of those 5,000, I want to match them to a user in the users to array. And in this case, I'm doing some funny logic here to reverse the IDs. So the IDs are going to be different. The idea is that we want to match based on some other properties. So users to, if we look at that, users to, now we have the same user, but a different ID, right? And we want to match up 1001 to 9000. Make sense? We're going to match users. That's basically what we're going to do. So in this case, we're going to match based on the email address. So that's what I ended up doing for the project I did this for. I used the email address to match it. So there's a lot of ways we can match users. So we're gonna start slow and finish very quickly. So for example, this first way we're gonna do it is for each user, user one and users one. So users one, that's the 5,000 user array. I want to find the user and users two that has an email that matches the user in user one, right? So I'm gonna say users two, where object email equals that user one.email, but select the first one. So it's, as soon as it finds that match, that select object tells it to stop iterating. So it's only gonna get the first one. So actually, that saves a lot of time in and of itself. And then, so if it finds a match, it's gonna output it, okay? So let's see how long this takes. And the joke here is that it takes so long, it's not worth waiting. So where object is really slow. Yeah, I love the comment, where object. Thank you for that. And so actually, let's look at the diff here really quick. Let's see, user matching. What did I say? This was. Oh, I don't actually have the. Oh, there we go. I did actually wait long. It's 25 seconds. So that actually seems pretty reasonable. We're matching 5,000 users, 25 seconds. If we did the math, it's not very much time per user. But what we also want to look at here is we can use, instead of using where object, we can iterate over them using for each and using, if it equals, right? And then output it. And then we're going to use the break. This is very similar logic. It's just more verbose compared to where object. So for each user and user two, or sorry, for each user and user one, and then for each user and user two, if it matches, then we're going to output it. Oh, and my wife just sent me a text. Give me a second. Oh, how's it going? Oh, it's going great. So if we run this section, so we're doing the same logic as you did with where object, but we're using for each. It only takes 5 seconds, a little over 5 seconds. So that feels pretty good, right? 5,000 users, 5 seconds. Now, see, that's math I could do, right? So 1,000 users per second. And so, but is that really, is it anybody here satisfied with how fast that was? I hear a resounding no. Yeah, there we go.
No.
So another way we can do this is one of the things, if you guys haven't heard this, is that arrays are slow in PowerShell. Adding and removing from arrays, because every time you add and remove, you have to destroy it and create it. And so my thought is, every time we match a user and users two, we no longer need to worry about matching that user again. So let's remove it from the list of users, and then that makes it faster the next time it iterates through it, right? So the next time it has 9,999 users to match through, and then 98, 90, etc. So I'm going to build that same array, but I'm going to use it as a generic .list of PS objects. And now I'm going to, let's get this out of here. So I'm going to use the same logic as with my, I'm going to use a for loop in this case to iterate through them, because in a for loop we can, modify that that list inside of the for loop. And so I'm going to say for each user 1 and users 2, and I think I had someone say be careful about singular and plural variables in the for each loop. It can be easy to mix them up. That is a very good call out. And then I'm going to iterate through the users to list for each of them, and then do a comparison. So if user 1 is equal to the user2.email, I'm going to output it and then I'm going to remove it from the list. So I don't have to worry about that user at all anymore. So let's run this command. Do you think it's gonna be faster than the 5 seconds? Holy crap, that was 75 milliseconds. A lot faster. But is that fast enough?
No, we want.
No, that's not fast enough. So actually, if I had been thinking about it at the time, I may have stuck with something like this. But I did the where object and then skipped ahead to hash tables. So the hash tables. So we're going to import this as a hash table, and then we're going to tweak the data to make it easier to do the comparison. And so what I'm going to do is I'm going to take each user and convert the user so that it is the email. So the property we're using to match the users is now the key. Value becomes the actual user object itself. Yeah, thanks guys for the gifts. And so this way, because looking up items in the hash table is very fast. So if we do hash table.contains key and the key happens to be the email, if that returns true, then we know it exists, right? So we're going to do this with these couple blocks here. So user 1's hash table, we're going to, for each user and users 1, we're going to create that object. And then for users 2, the same thing as well. So if we look at users 1, and we'll use this example, and this is fake data, don't worry. And we look at that value in the hash table, and now, did I typo this? I thought for sure that maybe that 0 isn't supposed to be there. Maybe it's only users 2. That's weird. I'm a little surprised that isn't there. Well, let's make sure that actually is the data in users 1. Okay, there is data. It's because I did users 1, not users 1 hash table. Did anybody catch that? Nobody caught that. Okay, cool. Oh, and there is actually a 0 in it. I thought that might have been a typo. Yes. Okay, there we go. Let me struggle over this for a minute here. So the user does exist, and it's using the email address as the key. So we go users HT or users 1 HT. We get this huge hash table where the value is the email address, and then the key is the email address. The value is the actual user object. And I'm doing this so that I can do this very simple. Yes, you did warn me about variable names, Stephen. Appreciate that. So I doing this so that users2ht.contains email. So this contains will return true if that email address exists as a key in that hash table. So how long do we think this is going to take? Faster than 75 milliseconds, I bet. Yeah, 35 milliseconds. We're getting the same data every single time. Yeah, there we go. Finding 5,000 matched users. So, and yeah, let's go faster. I appreciate the enthusiasm. So one of the interesting things that I tried in preparing for this is that what if we removed the key as we went? Does that make it faster? Because it made it faster with the list. So doing this is actually slower. I was a little surprised about this, but it's probably because the remove operation is so slow compared to contains and pulling that data out. And maybe this would be not the case if it was a huge hash table. I'm not sure. There's only so much scale that is really worth demonstrating. But that was just a fun little thing I ran into. But also, let's look at using the dash contains instead of dot contains and see if this is any faster. I think the time to beat is 35 milliseconds. And that was significantly slower. So this is a use case where we have a much larger hash table, and dot contains is much faster than dash contains. So yeah, that's what I got. So actually no, that's not what I got. I have a little slide to wrap this up. So the moral of the demo is that hash tables are better for performance, and PS custom objects are better for presentation. So if you're outputting PS custom objects, if you need to work with a lot of data or work fast with the data, hash tables are the way to go. So that's the moral. I think that's the last slide. Oh yeah, any questions?
But yeah, if you're working with data at scale, the other way. But yeah, hash tables for the win. Thanks, Anthony. I really enjoyed it. It's always good to get deep into the weeds, and I think it's fun. I think the chat was definitely livening things up, and really appreciate you sharing with the group, and I really appreciate it. So,
I appreciate. Well, let me turn my camera on. I sort of really appreciated the last sort of run through to see the orders of magnitude of speed increases. Just, I mean, forget about all the examples at the end, contains key and all that. Obviously, there was speed improvements there and meaningful, but just coming down from like where object and just moving to a modern method, just unbelievable.
It's
How
about
much?
the big O.
What was that?
It's about the big O notation, which handles time complexity. I mean, it's a serious thing.
Did I miss something? The big O notation?
It's a computer science term as to how many O is it. It's how fast it is. Is it N? It's logarithmic. O.
Yeah.
How logarithmic is it? It's a CS thing. It's a computer science thing.
Okay.
Yeah.
Nice. Okay. Yeah. Thanks for that explanation.
Yeah.
Anthony, I thought this was really awesome tonight, man. I thought you did a fantastic job.
Thanks
Well, thank you. Yeah, for me personally, like I'm very passionate about writing performance scripts, and so the hash tables is a very strong point for me. I convert a lot of people to using hash tables, in my day-to-day job. I'll highly recommend it.
All right, so that was a look at PS custom object versus hash table, and as I was started off the talk, I was right. So. What I'm right about, I don't know, but I'm right.
Thank you everybody for joining us, and don't forget that this is posted onto YouTube. If you're watching this now, you are watching on YouTube, but don't forget to check back there and check over there and check all the other videos that are available for us. But no worries, you can join us at the first Wednesday of every month. Certainly reach out to our website, rtpsug.com, and reach us up on Meetup, and we'll happy to have you and come and join the fun. You can hear we enjoy each other together and have a good time with each other so much.